Okay, now we are in question number 16. Let me read out the questions. A triangle PMN and a parallelogram RMNQ are constructed on the same base MN. We have a base MN. We don't know, right? We're going to draw that. And we have a triangle. Sorry. We have the same base MN, and between the same parallel lines MN and PQ, we have two parallel lines MN and PQ. I just drew it, right? Then we have a make a triangle PMN. PMN. Let's draw that. Let's draw this, which is PMN is like this, right? So this is PMN, and prove that this area of triangle PMN is the half of area of RMNQ. Where is the R? I don't know R, right? We don't know R. However, look at here. What do you know? NQ. NQ means I have to join this. Okay? I have to join this because there is a NQ. So R should be somewhere. This is a parallelogram, so this should be, another side should be parallel to this. So I have to draw this one here. This is R. Okay? Now we have, this is a given condition, right? You can draw either way. So we have a given triangle PMN and parallelogram RMNQ. RMNQ. They are standing on the same base and between the same parallel lines. Between the same parallel lines. Now your job is to show the area of this triangle is half of the area of this parallelogram. Right? We have to show the area of this triangle is half of this parallelogram. How do you show? Firstly, let me make one construction here. If I construct like this, let's draw a line parallel to MP. So let me draw a line parallel to MP like this, which is, let me call this is to be T. Draw NT parallel to MP. Look at here. Draw a line NT parallel to PM or MP. This to this, right? Now what do you see? PM and Q is a parallelogram, right? Because this is also parallel line, right? Now these are also parallel line by our construction. Now can you see this? PM is a diagonal. Diagonal divides the parallelogram into two equal parts. So this and this part are equal. Also, so I mean this plus this equals to area of the whole parallelogram. Directly what you can see, the area of this triangle is a half of area of this parallelogram, right? Because diagonal divides into two equal parts, means this is half of the whole thing. That's done. But I don't have to show the area of this triangle is half of this parallelogram. However, you know the theorem. If there are two parallelogram or any quadrilateral on same base and between same parallel lines, then their area would be equal. Look at here. I have a two parallelogram PMNT and RMNQ. Their area should be equal because they are standing on the same base and lying between the same parallel lines. These two areas are equal. And this is the half of the whole thing. So obviously, this is the half of this. That's how we have to prove. Okay, let's just start solving this problem. Solution. What are the given things? Write down. MN parallel to PQ. That is given. This is a parallelogram. RM and Q is a parallelogram. Parallelogram. Oh, you have to write down given, right? So given I have very small space, that's what I have to utilize more, right? So construction. What do you do in the constructions? Draw a line NT parallel to MP. Draw NT parallel to MP. This implies what? MN TP is a parallelogram again. Now this is a parallelogram. To prove, what is to prove? Area of this triangle PMN is equals to half of area of parallelogram RMNQ. That's we have to prove, right? That's what we have to prove here. Now proof. It's a very short proof. Number one, fact and reason. Okay, you can make a table, but I'm going to write down without the table and I will draw after. Maybe after. Number one, what do you know? Area PMN area of triangle PMN is equals to half of area of parallelogram, which one? MNTP. This triangle is half of the parallelogram because it's a diagonal, right? PN is a diagonal. Write down the reason why. The diagonal PN divides PMNT into two equal parts. Right? So this diagonal divides into two equal parts, half here, that means this is the half of whole thing. Number two, what do you know by the theorem? We have a two parallelograms standing on the same base, PMNT and RMNQ, their area must be equal. So area of parallelogram MNTP equals to area of parallelogram, because there are two parallelograms, their area must be equal, being standing on the same base. Look at here what I do. One parallelogram PMNT and RMNQ, their area must be equal, because the reason is parallelogram, two parallelogram standing on the same base, and between same parallel lines. Because the two parallelograms, their area must be equal. Number three, from 1 and 2, substitute the value of this guy from here to here. Just replace this means this right there. So now just copy number 1. Triangle PMN equals to a half is a half, and this guy means we have here area of parallelogram RMNQ from 1 and 2. From 1 and 2. That's what you need to prove. Now you can say it is proved, hence proved. getting it? 3 lines. 3 lines of proof. Only you need to understand how to make a constructions. So when you do the constructions, you have to say, okay, I have to draw a line NT parallel to MP. Then when I have a parallelogram, this is a diagonal and PN is a diagonal, and this divides into 2 equal parts. Okay, so I wrote, okay, this is the area of triangle equals to half of the whole parallelogram because the diagonal divides into 2 equal parts. Now we have another PM and T is a one parallelogram. We have another parallelogram standing on the same base, lying between the 2 parallel lines. Their area must be equal. So 2 parallelograms have equal area. By substituting the value of this from 2, right? This means down here. So substituting back here, I got the exact thing that I need. Hence proof. That's it. Thank you.